Part of this histograms question asks you to, well, it tells you basically that the height of the 31 to 35 bar in the histogram is 5.6 centimeters. And the height, you should know that the height of each rectangle in a histogram is what's called the frequency density. So what I'm going to do is I'm going to work out the frequency density for this group. And to work out the frequency density, which is the height of the bar, as we've just said, is the frequency for each group divided by the class width. Now, if we look at the group 31 to 35 group, the first thing that we've got to realize is that the frequency is just 28. The class width, though, we have to be careful because this group goes from 31 to 35, but there are gaps between the groups. The previous group stops at 30, starts at 31, but we're talking about time in minutes, so the times must have been rounded to the nearest minute. So in fact, this 31 to 35 group actually goes from 30.5 minutes right up to 35.5 minutes. So the class width, so the difference between 30.5 and 35.5 is actually 5. So the frequency density is 28 divided by 5, which comes out as 5.6. And we're actually told that the height of the rectangle that represents that group is exactly 5.6 centimeters. So the scale then on that vertical axis is just 1 centimeter to 1 unit on the frequency density axis. It then says, what is the height of the 28 to 30 class? Well, that's this one. Now for that class, the frequency density is again the frequency divided by the class width. The frequency here is that 4. The class width actually goes from 27.5 to 30.5, which is 3. So the frequency density is actually 1 1/3. So the height, because the scale is just 1 centimeter to 1 unit, the height is actually just going to be 1 1/3 centimeters. Okay, the next part of the question asks us about the median, and it asks us whether the median is going to be larger or smaller than or equal to 33. So first of all, let's work out where the median group is going to be, and let's just see if they've actually got the right group there. Now the median group, because we have 50 people, the median is actually going to be between the 25th and the 26th person. So to work that out, we do 50 plus 1, divide the answer by 2, and 51 divided by 2 is 25.5. So the median is between the 25th and the 26th. Now if we work out the cumulative frequency, it helps us to think about where the median is going to be. So the cumulative frequency goes 0 and then 4, and then we do 4 plus 28, which is 32. 32 and 14, well, that's just 46. 46 and 4 is 50, and it's 50 here as well. So the cumulative frequency tells us that the first 4 people ran somewhere between 27.5 and 30.5. The next 28 people, which takes us up to the 32nd person, were all in this group here. So the 25th and 26th person must both be in the 31 to 35 group. But let's just remember that that 31 to 35 group actually goes from 30.5 up to 35.5. Now, if the people were evenly distributed across this group, you would expect the median to be exactly halfway between 30.5 and 35.5, which would be at 33. So let's just have a look at the people. We know that the 4th person must be, let's assume that the 4th person, or in fact the 4th fastest person, is going to be here, and the 32nd person, this is assuming that all these 28 people are evenly distributed across the group. Let's assume that the person with the 4th fastest time is about here, the person with the 32nd fastest time is about here, and everyone else is evenly spread across the group. Well, we know that the median is the 25th to 26th person, 25th and the 26th person. And we can see if the 4th person is here and the 32nd person is here, then the 25th and 26th people are going to be sort of somewhere around here. In other words, higher than 33 minutes. That's just, I mean, it's only an assumption here. We are assuming that all these 28 people are evenly spread across this group. So you've got 28 little people across here. The 25th and the 26th are going to be pretty close to the 32nd person, so they're going to be round about here. So I would expect the median to be higher than 33, and that's what I'd write there, and this would be my reasoning. Right, the next part asks me to work out the mean and the standard deviation. So what I've done is I've started creating a table here where I've taken the midpoint of each group. So the first group, I can ignore the first and the last one because there actually isn't any frequency for those. This group, the 28 to 30, the midpoint comes out as 29, and so on. And I've just copied down the frequencies. Now, to find the mean, we know that the mean is the sum of xf divided by n, and n is the sum of the frequency column. Well, we know in this case that's actually just 50, because these add up to 50, and we're told that there are 50 runners. So I'm going to do x times f, so 29 times 4, that's 116, 33 times 28, that's 924, 40.5 times 14, that's 567, and 53 times 4, that's 212. And if we add those together, that comes out as 1,819, which means that the mean is 1,819 divided by 50, and that comes out as 36.38, so 36.38 minutes. Now, to find the standard deviation, what I need to do is the square root of sigma x squared f divided by n, which in this case is 50, take away the mean squared. So I need to create another column here, which is going to be my sigma x squared f column. Okay, so I'm going to do x squared f this time. And the easiest way to do x squared f is just to do the x column multiplied by the xf. So I'm going to do 29 times 116. Well, that's 3,364. 33 times 924. That's 30,492. 40.5 times 567. Well, that's 22963.5. And lastly, 53 times 212, which is 11236. And if I add that lot together, that's the sum of, so sigma x squared f, that comes out as 68,055.5. So if I carry on and work out my standard deviation, so it's the square root of 68055.5 divided by 50, take away 36.38 squared. Now that comes out as the square root of 37.6056, and that's 6.13234, which is 6.13 minutes. So that's my standard deviation. The question now says that they do a bit of retiming and they discover that the winning time was actually less than 27.5 minutes, which means that there is actually a 1 in this column here. So there's one person who actually got a time of less than 27.5 minutes. So they're actually now in this group here. Now what's going to happen is that the mean is going to be reduced because you've got one smaller time. The standard deviation, because everybody else's times stay the same, but this time is actually now further away from the mean, it's actually lower, the range of times is actually going to increase, and the range of times affects the standard deviation. So the standard deviation is actually going to increase. So the standard deviation will increase because the range of times is slightly larger. The mean, as I've just said, is going to go down because we've got a shorter time. The median, because the median is only the middle value, all that's happened is the smallest value has changed, which means the middle value is going to be the same. So the median is going to be the same as it was before, and the upper and lower quartile as well. In this case, we've got 50 runners, so the runners which are a quarter of the way up the field and 3/4 of the way up the field, their times aren't going to change. So the interquartile range, the difference between those times, is not going to change either.